Oh. Y'all didn't even say nothing. I forgot to record. It's all right. Y'all live. Hmm. Yeah. All right. While she's copying, y'all could ponder how to do this one. I know you guys know how to do it already. Mhm. 7N? Hmm? So, yeah. How'd you do it though? All right, so here's the process, right? You have the negative right here. You're gonna distribute that onto every term to the right, right? So then what do I have now? I have 5N plus 8 minus 2N plus 1, right? Now combine like terms. What do you have? 3N plus 9, good. And that's it. Y'all remember that? Distribute the negative first and then combine like terms. Right. Right. Well, a negative times a negative is positive. Right. Like that's what I'm really multiplying by, like a -1 imaginary. All right, all right. I know y'all definitely know how to do this one, right? It's like homework too, right? Or was it homework 3? I don't remember. It's one of them. -40? That could be right. I don't know. Because honestly, like I haven't done it, so I don't know. I just like trust your word. Oh man, can't forget that square. So no, just to the Y. Could be. I don't know. I didn't do it yet. You might be right though. So I'm looking around the room. I don't see nobody with groceries. So nobody went to pantry. Uh-huh. Yeah. Yeah. What did it say? You can just show up though. No, you just show up. You have to fill that out before you go, but you just show up. Yeah. 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 For real? ARC. What time is it? Yeah. 10. Yeah. Really? Yeah. Oh man. Yeah. Y'all could have also just showed up. Yeah. Yeah. I got names. Sorry. Yeah, pretty much. That's it. I mean, they might be like, "Oh, fill out the form there," but then they'll still bless you, right? You know, it's a one-time fill out. It's not forever. You know? Yeah. But so once you fill it out, you just walk in. Yeah. After that, they just like After that, they assist you in making appointments going forward. Yeah. Every 2 weeks. Yeah. 2 weeks from now. Yeah. 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 I think they can still go. No, but isn't it one day in the summer now? Yeah, I think it's just today. I mean, yo, if y'all want to try tomorrow, go ahead. But because in the school year, it's Wednesday and to Thursday. But I don't know right now though. Yeah. Yeah. I'm online in the email. It said just Wednesday. So yeah. 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 They make smoothies. Oh, I don't even know. I didn't even know they had smoothies. I know they have some kind of class thing, right? Where they'll teach you how to cook or something. Yeah, I could have swore they had some cooking classes or something. We have a classroom kitchen up in here. Like we could be doing our own food here. Yeah. There's a club for it, yeah. But we have the what's the right word? Facilities to actually do like hospitality management here if we wanted to. Yeah. I don't know why. That's why I said you gotta create it. They ain't gonna listen to me. No, you know how many times I've been singing that song over here. You got your back right here. Yeah. I'd appreciate that. Oh. Who? All right, before we get into that, this for you. That's their number and where they're located. Yeah. You're welcome. I think the hours might be the same also. Huh? Not on the website. I think they emailed that out to everybody. What? On the website, it says that they have an Instagram, so I don't know. Oh, yeah, maybe. Yeah, maybe add them and stuff, you know. Mhm. You probably have a big thing too. That's part of it. You know, their Instagram. Like Instagram, and they'll probably have pop-up shows. On campus, but not off campus. Yeah, 2 weeks. Yeah. I mean, fill out the form. Yeah. So yeah, just call them, like and help them tell them to make you an appointment and just show up. Mm-hmm. Yeah. You said they have good stuff. They do real nice stuff. Ain't nobody grab nothing to show off. Like they have meat, for example. A lot of pantries don't give out meat. Like they have meat, and then they have vegetables. Fresh vegetables. Yeah, produce stuff. You said they have other stuff besides vegetables. Yeah. That has chicken breast. Like the first time, they want to give you 2 chicken breasts instead of like a whole pack of chicken. Wow. Now, so with me now, right? We're only allowed to go the last day after 5 o'clock. Oh, so whatever, yeah, whatever the students don't take, that's what we get access to. Yeah. Because there's a lot they have a lot of. And then also the stuff that doesn't perish, like the canned goods, all of that goes away. Like we have no access to that. It's like strictly just not even the meat, because the meat is frozen, right? It's just the fresh like fruits and stuff that we have, vegetables. Yeah. Oh, that's crazy. That's how it is. Sad thing is, when I was a student, I didn't even know they existed. Right. That sucks. Anyway, let's look at this, right? So how come it's only distributed to the Y? Because it's on the Y. So if it was in direct to schools, it would be distributed to X and Y. Yes. Like if the 4XY was in parentheses, yeah, everything. Because it's only in text. Exactly. So let's look. We have 4 open parentheses, close parentheses, open parentheses, and then this is squared, right? Plug in the -2, plug in the 5, right? We know that we do our exponents first, so 5 squared is 25, right? -2 times 25. And then you just have to multiply this straight out. I'm not even gonna hold y'all. I'm gonna do some funny stuff here. Yeah. I was gonna do 25 times 4, 100, and 100 times -2, -200. Because I was looking at it, I was like, 4 times 2 is 8, but yo, what's 8 and 25? Damn. Yeah. I should know that though, because of the MTA. Yeah, it was 4 quarters. 8 quarters is yeah. I'm kind of mad at them though. All right, so let's get into this lesson. So we want to determine the degree of a polynomial, right? This is really important for Math 30. So we have learned that a term is a constant or the product of a constant and one or more variables. A monomial is an algebraic expression with one term. When it is of the form ax to the m power, where a is a constant, m is a whole number, it is called a monomial in one variable. Some examples of monomials in one variable are 2x, 5y, 17z, 4y squared. Monomials can also have more than one variable, such as 5abc and -4a squared b to the third c to the second. All right. Or that formula that they have in bio, what was it called? Photosynthesis? Something like that. Yay, plant cells. Wow. So they talk about monomial. What about power? Oh, we get into that. Yeah. So monomial. A monomial is an algebraic expression with one term, right? So monomial, one term, right? A monomial in one variable is a term of the form ax to the m power, where a is a constant and m is a whole number, right? Not a fraction, whole number. So we're clear. Okay. Wait, what? Huh? Yeah, so the m is a whole number, not a fraction. Never be. It can be, but we're gonna get to that later in the semester. Yeah. But for this like conversation right now, it's a whole number. So a monomial, a monomial or 2 or more monomials combined by addition or subtraction is a polynomial, right? Some polynomials have special names based on the number of terms. A monomial is a polynomial with exactly one term. A binomial has exactly 2 terms. A trinomial has exactly 3 terms, right? There are no special names for polynomials with more than 3 terms, right? Yay, poly. Nah, none of that. There probably is a word like quadnomial, but nah, our vocabulary doesn't go that high. Yeah. So it can never be multiplication. No. Oh, it has to be addition and subtraction for polynomial. So just so that we know the difference, let's take a look at it. So polynomials, right? Polynomial is a monomial of 2 or more algebraic terms combined by addition or subtraction, right? Is a polynomial. Monomial is a polynomial with exactly one term. It's called a monomial. Binomial is a polynomial with exactly 2 terms, called binomial. Trinomial is a polynomial with exactly 3 terms, and it's called a trinomial. All right.
So it would be AX7 plus AX7 plus AX7 for trinomial.
Mm-hmm. Or like, like the quadratic when you be like, x squared plus 3x plus 5, like that's trinomial.
I remember.
Yeah, I got you. But since you asked the question though, right? Let's look at some examples so you can better see it. All right, so check this out, right? So polynomial is going across, right? Like each row. Polynomial would be like y plus 1, right? Also 4a squared minus 7ab plus 2b squared, still polynomial. Also 4x to the fourth power plus x to the third plus 8x to the second minus 9x plus 1. All of that, polynomial, right? Monomial, one term, right? Notice in the monomial, there's no addition or subtraction. It's just one term, right? So like 14, monomial. 8y squared, monomial. Negative 9x to the third, y to the fifth power, monomial. Negative 13, a to the third, b to the second times c, monomial, right? Binomial has an addition or a subtraction, but only two terms, right? So for example, you have like a plus 7b, 4x squared minus y squared minus 16, 3p to the third power times q minus 9p to the second times q. Trinomial, three, right, has three terms. So for example, you have like x squared minus 7x plus 12, 9m squared plus 2mn minus 8n squared, 6k to the fourth power minus k to the third plus 8k, or z to the fourth plus 3z to the second minus 1. Right? So notice that every monomial, binomial, and trinomial is a polynomial. There are special members of the family of polynomials, and so they have special names. We use the words monomial, binomial, and trinomial when referring to these special polynomials and just call all the rest polynomials. The degree of a polynomial and the degree of its terms are determined by the exponents of the variable. A monomial that has no variable, just a constant, is a special case where the degree of the constant is 0. All right? This is something big for Math 30. We'll need this. Mm-hmm. Going across, right? So the first row is a polynomials. The second row is monomials. The third row is binomials. And the fourth row is trinomials. Yeah. So count how many terms they have. That's the difference between. So like, you see like with the monomial, there's no addition or subtraction here. It's just one term. That's a monomial, right? For binomial, there's two terms. There's some kind of addition or subtraction in the middle, right? Two terms, two terms, two terms, two terms, right? That's the binomial. But for the trinomial now, right? Now it's three terms. You see that? So three, 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 three. Yeah. All of them are polynomials. Yeah. A binomial or a trinomial. Mm-hmm. Yeah. Mm-hmm.
If you put the plus sign, is that a polynomial?
Okay.
Yeah.
But it without,
If it doesn't have a plus sign, then
that's a lot.
it's a monomial.
Mm-hmm.
So.
Mm-hmm. Negative 9x. This right here?
Yeah.
So there's no other term being added or subtracted from it. It's just one unique term right there. Yeah, so that's a monomial. Right. Hmm? Yeah. So polynomial, all of them are polynomials, right? The second one is binomial, right? You mean? Or monomial? This one, right? It's a polynomial. It's also a trinomial. Yeah. So think of it like this: they're all polynomials, but trinomial is a type of no, excuse me. Trinomial is a type of polynomial that has three terms. Okay? Trying to see where that is. Oh yeah. Trinomial. All right, let's say it's a monomial. Yeah. But it's a special monomial where the degree of the constant is 0. So it's like 14x to the 0 power, for example. That's what that is. Exactly.
So how is just a number without letters?
Well, there's a letter, x to the 0 power. Because anything to the 0 power is 1, right? So 1 times 14. Imagine it. Imagine the x. Yeah.
Well, if there's nothing.
Mm-hmm.
Or why does it be any letters?
Exactly. Not always be like that. So let's look at this. Mhm. So degree of a polynomial is what we're going to get to next. Okay, degree of a polynomial. The degree of a term is the sum of the exponents of its variables. The degree of a constant is 0. The degree of a polynomial is the highest degree of all the terms. Any questions? Okay. It's a little vocabulary. Mm-hmm. Right. Mm-hmm. Not quite. Like that one is asking about the degree of it, like how big is it?
Can we get an example?
Mm-hmm. That's coming. All right, let's see how this works by looking at several polynomials. We'll take it step by step, starting with monomials and then progressing to polynomials with more terms. Let's start by looking at a monomial. The monomial 8ab to the second has two variables, a and b. To find a degree, we need to find the sum of the exponents. The variable a doesn't have an exponent written, but remember that means that the exponent is 1. The exponent of b is 2, and the sum of the exponents 1 plus 2 is 3, so the degree is 3. Questions on that? We just add up the powers of the variables. All right. So we have 8 times A times B to the second, right? Our exponents for the A is 1 and for the B is 2. So the degree of the polynomial, we add 1 plus 2 to get 3, right? Here's some other examples. Go ahead.
A is over one, B is
In this case, yeah, in this case. So for monomials, right? When we have just the plain 14, the degree on there is 0 because x to the 0 power is 1, right? The 8ab squared, right? The degree we know is 3 because we just add them together. The powers of a and b, right? So that's the 1 plus 2. Same thing with the next one. We have -9 x to the third, y to the second. Excuse me, y to the fifth. What am I talking about? Yeah.
Ben, -13A is a one.
Yeah. Because what's the power on top of the a?
One.
As you can see it. Yeah. And then for
Then
the
why isn't it-
because 14 is x to the 0 because that's 1. Yeah. So basically like you can't see the x in 14, right? So that's the 0 power. But you can see the x in the -13, so that's the 1 power. You think of it like that. And then last we have the -9 x to the third, y to the fifth. Sum those powers together. 3 plus 5, that's our 8. Right? Sorry, don't worry. The questions won't be so
I
bad.
think once we start doing it.
Yeah, real quick. Binomial, right? The degree of each term, right? And then we have the degree of the polynomial. So if I have h plus 7, that's a binomial. The degree of each term is 1 and 0. So the degree of the polynomial is 1. Right? We always take the highest power. Next, we have 8ab squared, right? The degree is 3. Excuse me, no. We have 7b squared minus 3b. Excuse me, I'm sorry about that. The highest power over there is 2. Lowest power is 1. Always take the highest power for the degree of the polynomial is 2. Next, we have x squared, y squared minus 25, right? We're going to sum those powers together because they're next to each other. 2 plus 2 is 4. And we take 4 because that's the highest power level. 25x to the 0 power. Yeah. Okay? It is. That's why.
Right, that's what's the.
Yeah, that's exactly it. You're right. And it multiplies it by 1.
Because there's no, so the term
Mhm.
basically is what letter is next to.
Yeah, pretty
So
much.
basically, there is no letter next to that.
Right.
0.
Right. Let's see what else we have. 4n to the third plus 8n to the second, right? We have 3 from the n to the third. We have 2 from the n to the second. Choose the highest one, which is 3. Done. For trinomial, right? We have the degree of each term and then the degree of the polynomial. So we have x to the second minus 12x plus 27, right? So our powers are 2, 1, and 0, and the degree of our polynomial will be 2. Right? Always grab the largest possible power. Next, I have 9a squared plus 6ab plus b squared. Each one has 2, 2, 2. Right? So that being said, the degree of our polynomial will be 2. Because they're all 2s. Can't beat them. Right, nothing higher. Next, we have 6m to the fourth minus m to the third, n to the second, plus 8mn to the fifth. Right? Highest power there is the 8m to the 6. Whoops, to the 6, right? And then 6 powers there.
So how do you get 2 from 8? Is it 8 times B?
Where do you see
AB
it? For 6ab?
Yeah.
So the 2 is a is 1, b is 1, 1 plus 1 is 2.
Plus.
Yeah. So when you have like a monomial with 2 variables being multiplied to one another, add those powers. Then you're good to go. Okay? Absolutely, yeah. So last one I have z to the fourth plus 3z to the second minus 1. Z has 4. 3z squared has 2, right? So we add those. Well, not add those. We take the highest one, which is 4, and that's it. Let me just shrink this real quick.
Basically, letter five, so it's to the power of one.
Yeah,
And then there's
when you can see it.
one letter together,
Yeah,
power of one.
right.
No, I don't want this.
This part? This part?
Yeah.
Can you make it a little bit?
Okay. Good. Yeah,
Why?
it's not bad.
Why, if this is, after, you should have to.
I mean, you still have to do them at 30, but it'll be easier because you know what they're talking about. All right, let's look at one last one. So a polynomial where I have y minus 1, right? The degree of each term is 1, right? And the degree of the polynomial is 1. 3y squared minus 2y minus 5, right? Find the take the highest power, and that's the degree of my polynomial. Same thing with the 4x to the fourth. Right? Highest power, boom, just 4. So work with polynomials is easier when you list the terms in descending order of degrees. When a polynomial is written this way, it is said to be in standard form of a polynomial. Right? Get in the habit of writing terms with the highest degree level.
Oh, so basically. Right.
Hmm? From largest to smallest.
Meaning.
Like how this is, yeah, like see how this is 4x to the fourth plus x to the third plus 8x squared minus 9x plus 1, like that.
So they basically, it was to give it a, less.
Exactly. That's it.
And I'm still going to see. Yeah, it's kind of.
Sure. It's not a problem. You guys try. Yeah, just give it to me. Yeah.
Oh, what the.
Monomial, binomial, trinomial, polynomial.
Do we need to tell you the term too?
Well, tell me what the highest degree would be. Yeah. It's 2, and what is that? What is A? What is A? Is it a monomial, binomial, trinomial, polynomial? Binomial. Yeah, how you know that? Well, how many terms are there? In A? Yeah. Yeah, trinomial, right? Right? And the degree is what? Good. How about B? Monomial. And you said 4. Yep. Well, hold on. They're being multiplied, right? So what do I do when they're being multiplied?
Oh, so they are being.
Because they're next to each other like that. The A to the 4, B to the second.
The other one, they were.
You add them, right? So this is actually 6, right? Huh? Because you add the powers here. Right. Because they're being multiplied together. Yeah. Mhm. How about C?
Triangle.
Holly.
Poly?
Yeah.
Oh, yes.
Degree 5. I agree. How about D? What is it? Binomial, okay.
Degree is just by next to.
Yeah.
Three.
Mhm. 3.
That's 6. I wanted a double.
That's about it.
And then E.
Oh, E? I thought E was cut off. I just realized. So what is that? Uh-huh.
0.
And then I heard 0. Okay. That was really good.
I didn't understand.
You don't understand C? Why? It's poly because there's many, many terms there. And the degree is 5, it's the highest power.
So when you say many minutes, X is still constant, doesn't matter if X5 and X3 can't combine. Two can. That's the rate.
Exactly.
One X5. So that's 12.
Mhm.
Don't have any name for it. Right.
Above 3. So just call it poly.
Then the other one, you don't need.
It's 3 because of the third.
Yeah.
No, that's D. B.
Oh, you said B.
Six.
B is 6, very good. Mm-hmm.
Still good.
Yeah. That should be everything. You guys try now.
Everybody. Over. Three, so the 3 by. The 3 by.
The whole one. It's like, is this a polynomial or?
Not a lot though, maybe like one or two. Like I just wanna see that you understand it, I don't need to like drown you in it.
So, first, I will go D is one.
Which one? Yeah, Z is one.
You got it, one.
Yeah.
That's 10.
Uh-huh.
It's a C. You meant the last. What's this? E. Oh.
Yeah, that sucks. Bless you, Lord. Oh. All right, what's A? Mon, okay. I feel lazy. And zero, good. How about B? Hey, I agree. C?
Five,
Mm-hmm.
three,
What is it?
three.
Three, okay. What's that other letter? D? By, good. E? Uh-huh.
10.
Mm-hmm. Good. I'm impressed. Hmm? Three for B. The highest power is three. You see on the Y? Y to the third? Mhm. Not in the poly situation. Yeah, only in the money. Yeah,
Real rate.
yeah. All right. We get the idea, right?
Yeah.
All right.
You said
Let's get to what
one
we, yeah. This ain't even gonna be the question. This is what's gonna be the question right here.
Oh.
Add and subtract polynomials. Okay, so we have learned how to simplify expressions by combining like terms. Remember, like terms must have the same variables with the same exponent. Since monomials are terms, adding and subtracting monomials is the same as combining like terms. If the monomials are like terms, we just combine them by adding or subtracting the coefficients. Cool, right? Oh, the number in front. Hmm? Yeah, the number in front. Hmm?
So like three x squared, the three will be.
Let's take a look. I'll show you. So let's look at A. Right? So I have 25 y squared plus 15 y squared. Now they both terms here, right, have a y squared, right? So I can actually add these two terms together. And how do I add them together? I add the coefficient, the number in front, right? So this is going to become what? 25 plus 15 y squared, or, oh shoot, what's that, 40? Thank you, 40 y squared, right? Right, just leave that. Mm-mm. No.
Kind of like a fraction. If they keep saying,
Yeah, I guess. Yeah. Let's look at B. I'm gonna change up the color real quick. So I got 16p q q. Let me say that again. I have 16p cubed, right? And then we have this minus times a negative. What am I gonna do with that? Right? Because I'm gonna distribute this. It's gonna become plus 7p q cubed. Notice they both have a pq cubed, right? So I'm gonna combine like terms by adding the coefficients. So 16 plus 7 is 23. Woo, Michael Jordan. I'm sorry. PQ cubed. Well, technically it's LeBron now, right? Whatever. Questions on that? Sure. Well, how about you guys try it? It's the same thing. Don't worry. Just with easier numbers. All right. They have the same variable, and the variable has the same power and all that. Combine the coefficient. All right, let's try it out. Oh, y'all gotta help me out with this. Damn. So I got 12q squared plus 9q squared is, yeah, 21q squared. All right, thank you, thank you, thank you. How about B? I got 8mn cubed minus a negative is a positive. So 5mn cubed. What's that? 13? Okay. N cubed. All right. Not bad.
That's what.
And subtract it. Yeah. You know what? Just because you asked that. How about this? Help me out with this. Somebody said no more blue. I'm gonna try rainbow. All right. So I have a squared plus 7b squared minus 6a squared. What do I do? What does that become? Negative what? A squared, Yeah, plus 7b squared. All right. Questions on that? Yep, that's it. Yep, that's it. I mean, you might have to type it in like that, but you know, same thing. How about B? So I got a u squared, not 6u squared. Plus 5u squared minus 3v squared, right? All right. So what's the answer? Mhm. Right. Exactly. This is the answer. Copy and paste. They don't have the same variables, right? So I can't combine them. They just stay separate like that. Yeah. M squared B. Where? The purple B? This one? The 5a squared plus 7b squared? Oh, yeah. That was U. Yeah, I got to work on my U's. Yeah. Even in real life, you know, that 3-point turn? You turn out bad. Yeah. That's rare though. -5. 1. Yeah. 1 minus 6. Yeah. Because they have different variables next to them. It has to be the exact same thing for me to combine it. You try. You know what? I just remembered I didn't even give y'all no homework for tonight.
You gotta study
Y'all got a whole weekend. Y'all be good. I know y'all not coming to tutoring, so y'all must be good. Must be light. Got you. Let me take a look. Let me take a look. Trying to get y'all another 30, you know? Yeah.
Could it be this one?
Mm-hmm.
Oh,
Yo, my fault, I messed up. Well, y'all got his 10.
Five.
5?
okay.
Nah, actually, I just deleted like 20 questions off of it.
I'll take it.
All right, let's take a look at this.
Five.
Yeah, I agree. 5y squared plus 3z squared. Very good. How about B?
So, that's good. Oh, that's good. Okay.
Very good.
Oh, it's the
Yeah,
same.
no.
Good job. All right. So we getting this, we getting this. All right. Oops, okay. So we can think of adding and subtracting polynomials as just adding and subtracting a series of monomials. Look for the like terms, those with the same variables and the same exponent. The commutative property allows us to rearrange the terms to put like terms together. All right? So here's what they mean by commutative property, right? I'm gonna show y'all real quick. It's a little bit of an extra step, kind of not necessary. If you can look at this and do it, but I'm gonna show you. Yeah. So commutative property is saying that I could do this. I could say 7y squared, and I could put the other term that's like it next to it, right? Plus, right? 4y squared, right? Cross them out so I don't get confused. Minus 2y minus 8y, and then plus 9 minus 7, right? So what I'm doing here is I'm dropping these parentheses, just so you know. And I'm just putting the like terms together. After that, you already know, right? Let's see, we got this one right here. So 7y squared plus 4y squared is 11y squared. Then we have let's see, plus minus 10y, right? And then we have these plus 2. Very good. And that's my final answer. Questions on that? Nothing? We're good? All right. What's this do? We'll continue. Ba-da-ba-ba-ba. Right? You remember back in the day, they used to have like all the commercials with the jingles and stuff? Yeah. Yeah. I remember that. You remember the Nike commercial and all that? Yeah.
Gotta get the burger with the french fries.
Right. Now my favorite rap was the what's this one? The Optimum Cable one.
Oh.
Yeah. 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 Reese's Puff. I can't remember that one. Oh yeah, yeah. That was a good one. Yeah, good times, good times. I wish that commercials came back like that. Like, All right, you guys try. If you want to use the cumulative property, go ahead. If you could look at it and know what to do, go ahead and do that if you want.
So the X squared, so X squared,
That's what it's combining. Yeah,
Oh,
yeah. It did as well. The seven y squared and the four y squared, that's what combined.
So you only do.
Yeah, the like terms. Yeah.
So
X squared and seven X squared. But they can't combine with four X.
Oh.
Mm, it's adding. It's
Okay.
adding, yeah. Just the number in front. That's all you're doing.
I don't, yeah, so. X squared, X squared.
Mm-hmm. Yeah, 8x squared. Very good. That sounds good. All right. Let's look at this. So I heard, so I wrote the wrong thing. 8x squared. What is it?
Minus 11
Uh-huh.
plus.
Good. Questions on that? We all good? All right. All right, just checking here. Since we done mastered addition, how about subtraction? How we do this? What am I gonna do first? Hmm?
Combine.
Drop the parentheses, but I'm gonna do what?
So 9W minus.
Mm,
Well, 9W squared minus 2W squared.
I'm looking for you to say distribute, right?
Oh, one.
Distribute the negative first, right? So now I have 9W squared minus. Okay, let's do it like that. Okay, minus 2W squared minus 7W, not yet, plus 5 plus 4. Good. Right?
Wait, what is it? Plus 2W squared.
That's here.
9W minus.
So we're using the cumulative right here, right? So you already know. What's that? 7W squared. Bring you down, minus 7W. Can't combine that, and then
Nine.
what's this? Plus 9. Questions on this?
So anytime it's a negative.
You distribute and then combine like terms. Yeah,
But I did any.
always. Hmm? You guys try. By the way, if you get the gist of it, go ahead and do your homework. It's only like 10 questions. You could probably finish it in like 10 minutes. Hmm? Go up
Yeah.
like this. You're welcome. I'm sorry? Like in web work? Like this. So you do x raised to the 4 like that.
Oh, no, right.
Is that actual?
No, the let's call a caret. Yeah. So the shift and the number 6. Right? And then 4, like that.
Oh, shit. Oh,
Yeah.
the,
The caret, yeah. That's a Mac. Mac.
yeah.
Mhm. You okay? What happened?
Same problem.
Might have to do some parentheses with it. Might have to do some parentheses with it. All right, let's look at this one, and I'll show y'all how to type it in real quick. So it says to find the difference of 8x squared plus 3x minus 19 minus 7x squared minus 14. What should I do first?
Distribute the.
Mm-hmm. And then we have what? 8. Mm-hmm. What else?
And you're going 7.
Mm-hmm. What else?
Plus 14.
It's 14. Mm-hmm. So I'm distributing the negative over there, right? So now what we gonna do? We're gonna combine like terms. X squared, very good. Plus the 3x. What's that? Negative 5. All right, so this is my answer right here. All right, so let's talk about web work, right? If I wanted to enter this into web work, so I would enter, oh, I wouldn't do that. First, I would open parentheses, do x raised to the second, that's the caret symbol, right? Close parentheses, plus 3x minus 5. So that's how I would type this into web work. Okay. So anytime I have like a power, I like to put that in parentheses and then add or subtract. Yeah.
You did it?
Use the parentheses like this. Because the thing is, without the parentheses, right? Web work would probably think that it's like x raised to the 2 plus 3x minus 5 power. Like all of that. You know, and then that would be confusing. Yeah. Right. By itself. How is it? All right, what's the answer you got?
X to the 4,
Uh-huh.
5x squared,
Plus 5x squared plus what?
40.
So if I'm entering this, right, I'm gonna do open parentheses, x raised to the 4th power plus open parentheses 5x raised to the 2nd power plus 14. Right? So that's how I would type it in. Yeah.
It's still
Yeah.
saying not working.
But it's over.
Let me see.
Go with that.
I'm gonna have y'all work this one out because it's joint hard as hell. This is 4x to the fourth plus 5x squared plus 6 plus negative 4x to the fourth plus 8. Huh? Nah, that's his homework question. So, oh wait, yeah, I do pick the problems. Yeah. Help me out. How do I do this? All right, so we got 4x to the fourth minus 4x to the fourth, good. Plus 5x squared plus 6 plus 8, good. And we want to combine like terms, right? So what do I have?
Just X to the fourth.
What's 4 minus 4?
X.
0, right? So that crosses out. So I have what? 5x squared. And then what's 6 plus 8? 14? All right.
Also take off X.
And then that's it. But now to type it in though, I would do open parentheses 5x raised to the second plus 14, like that.
I wanna do the. So 4x to the fourth and minus 1.
Right. Cancels out. Well, that's it. Got you. It happens. It's all right. That's why we practice in the homework. Um, all right. So similar question. What do I do? So I heard u squared, good. Plus 3u squared, good. Minus 6uv
No.
plus e2uv, okay. How I do u again? That's it, uv. Uh-huh. Plus 5v squared, very good, right? Let's combine like terms. What do I have? So 4u, it's supposed to be a u. That's my fault. Yeah. Uh-huh. Mm-hmm.
4.
Mm-hmm. Very good. That's a u. Okay. I'll work on it. All right. So since we get that, you guys try. I'm impressed, by the way, because these questions got 2 variables now.
That's.
So it's a trinomial plus a binomial, which gives you a trinomial as an answer. Right. 3 terms. Yeah. Yay, vocabulary. Y'all playing words with friends. Y'all know y'all word for today is monomial, polynomial. Nah, poly is mad points though, because that joint got a Y in it. Oh, words with friends? Yeah, that's mad points right there. All right. Yeah. What's tomorrow again? It's like Thursday, I think. So I'll be online tomorrow if anybody wants to join. No pressure. Want to. So you make an appointment on the WC online. Yeah, because they're gonna give you a special link to join tutoring.
Oh.
That's why. Yeah,
Is it virtual?
it's virtual. Yeah. It's tomorrow on virtual. Then not here Friday, but they are open Friday if you guys want, online and in person, your choice. And Saturday and Sunday is online if you want, your choice. Saturday I'm there though,
Or 12 to
12 to 3.
3 on Saturday?
Yeah. I'm not gonna lie, this past Saturday I was there by myself. I was like, yo, am I doing something wrong? I was just sitting there. Yeah, yeah, it's in the email. It's like that picture that you sent, the last paragraph, the blue words there, that's the link. Yeah, yeah, straight to it, yeah,
Oh,
yeah,
yeah.
yeah. Yeah, the school got rid of blackboards, so I miss blackboard, shoot.
I know, what happened?
Yeah. So it's not us. CUNY Central decided that they wanted to get rid of it.
Why?
So
Let's see.
I don't know. That's just them.
Why?
Yeah.
I feel like it's easy to access.
Yeah,
Everything is one.
Yeah.
Like you got here, you work with my.
exactly. Yeah. Not everything got to go over to Brightspace. Yeah. I don't know. We'll see. We'll see how Brightspace turns out. Like right now, it's a pain because we'll have to learn it. But once we learn it, you know, I'm still learning it too. You see, all I'm doing is announcements because I'm still working that out. Yeah.
I guess.
But I feel sorry for him.
Blackboard breaks.
Yeah.
Feel that.
But who I feel, oh yeah, from Black to yeah. Nah, but who I feel sorry for, some people like they have their entire class in Blackboard,
Yeah, that's not.
you know, and it's like, dang, you gotta redo that whole thing this summer. That's mad
They're gonna
work.
have to do that.
Yeah, like it's mad
So they
work.
change everything was wrong.
Yeah. Like, oh my gosh. I mean, once you get it
Thousands
done.
of Students.
No, it's the professors I'm talking about.
Oh, I know.
Yeah, like they have
You have
to
to?
yeah, like they have to redo their whole class in Brightspace. Yeah, like it's epic, like it's a lot of work.
But I still have access to my Black.
So I think they're giving us access in case you want to look at something old, you know, like I still have access to my classes from when I was a student and all that, you know. Yeah, but if you, I don't know if it's maybe 1 year, maybe 2 years, 3 years tops, right?
Yeah.
That's gonna all die, and everything will be on Brightspace. Yeah. When I don't have the actual date for you, but that's coming in the very, very near future. Yeah. All right, let's take a look at this, right? So I have 3x² minus 4xy plus 5y² plus 2x² minus xy. Yikes, how I do this again? Mm-hmm. Mm-hmm. Good. Very good. Notice how I cross it out as I'm doing it,
Yeah.
right? Mm-hmm. So what's this? Then plus 5y². Very good. Not bad, not bad, not bad. That's it. Then of course, if I was gonna do that in web work, parentheses for the first term and the last term. Huh?
Oh, yeah. Whatever
Yeah.
to the power.
So yeah, so it'd be like open parentheses 5x raised to the second minus 5xy plus, and then open parentheses 5y raised to the second, like that. Yeah, that's just how I would type it in.
Where would you put the plus?
In front of it, yeah. All right, this next topic is gonna look mad hard because of the because of the vocabulary, right? But we've been doing this for the last 3 days. Or 8 days, whatever. It's literally the same thing with a new vocabulary word. So it says evaluate a polynomial function for a given value, right? A polynomial function is a function defined by a polynomial. For example, f of x is equal to x squared plus 5x plus 6, and g of x is equal to 3x minus 4 are polynomial functions because x squared plus 5x plus 6 and 3x minus 4 are polynomials, right? So that being said, a polynomial function is a function whose range values are defined by a polynomial. What does range mean again? Forgot. No. It's a letter. It's the something values,
Oh, the Y.
the y values, right? That's what it is. Domain.
Is the extra.
Yeah, so domain is the x, range is the y values, right? So long story short, right? I have a polynomial function, right? Who I'm gonna plug in some domains into it, some x values, and it's gonna spit out for me some y value answers, right? Those y values are ranges. That's what this means. The exact same thing. But a new vocabulary word. Speaking of which though, right? Since you mentioned that. So in graphs and functions, where we first introduced functions, we learned that evaluating a function means to find the value of f of x for a given value of x, right? To evaluate a polynomial function, we will substitute the given value for the variable and then simplify using the order of operations. Blah, 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 the same thing we've been doing all day, all week. Right? This should look like last night's homework. Exact same thing, right? Just plug it in. Huh? Oh yeah. Hold on 1 second. You want to see that? Okay, go. Hmm? You finished it all already? That's what's up.
Huh?
You finished it all already? All right, no problem. You got time. Alright, so this should look familiar, right? Let's look at A. I wanna do f of 4, right? It's literally the same thing. 5, open parentheses, 4 squared minus 8 times 4 plus 4. We do the math on that. This becomes 5 times 16 minus 8 times 4 plus 4. Not gonna lie, I need y'all help right now.
Yeah, $80, so.
That's 80, okay. Minus what?
20.
28,
No,
it's 32, okay. Plus 4, the question. Yeah. And then 48? Yeah, 48 plus 4, 52. Questions on that? If the math is wrong, that's y'all classmates' fault.
Or you keep the plus 4 to the side. So that-
Mhm. Same old, same old. Let's look at f of -2. So I want f of -2. So what does this become? This is gonna become 5 times -2 squared. Whoops. Minus 8 times -2 plus 4, right? Let's do the math on that. This is gonna become what? Hold up. We're freezing over here. Hold on one second. Okay, we're good to go. So this is 5 times 4, I heard, which is good. Minus 8 times -2 plus 4, right? Good. Good. And that becomes what? 20 plus 20? 40. Questions on that? Smaller? Wait. One more, then I'll make it smaller. Let's try C real quick. C is f of 0. This is the hardest one of all. So this is gonna be 5 times 0 squared minus 8 times 0 plus 4. Help me out. What's this? 5 times 0 minus 8 times 0 plus 4. Yeah. So this is 0, all right. Minus 0, all right. Plus 4. Good. All right, help me out. What's 0 minus 0 plus 4? 0 plus 4. All right. Yeah, I know I gotta check. Yeah, man. Low key, y'all didn't see me, but I was using my calculator because I wasn't sure. All right. Woo, that is small. Let me get it one more time. Nope. 40 is better. All right, there you go. This is nice. All right, you guys try. So yeah, stay on top of y'all homework. Y'all wondering, I can see how much y'all done. So y'all know. I'm just looking at some of the progress.
Don't give up.
It's interesting, like how the front of the room versus the back of the room is. It's real interesting, you know. All right. So what I do first for A? I want f of 3.
3.
Mm-hmm. Mm-hmm.
Square.
Mm-hmm. Mm-hmm. Good job.
5.
Oh, 15. Yeah. So this becomes 3 times, what's that, 9? All right, plus 2 times 3 minus 15. So what's that? 27, good. Plus 6 minus 15, good. 33 minus 15, 18. All right, I like that. Questions on that? Mm-hmm. Yep. That's it. Let's try B. They want f of -5. So that's going to be equal to what? Uh-huh. Very good. All right. And then what's this become? Very good. Very good. And then what's uh-huh. Very good. Very good. All right. I like that. All right. What was the last one? I didn't even catch C. 0. All right. Oh, this is not listening to me. Hold up. Oh, hold up 1 second. We freezing.
So C is
-15. Yeah. Of all times to freeze, right? You're gonna freeze right now. Oh my gosh. All right, the answer is -15. Y'all know. Like really? Oh, that's crazy.
Yeah.
Yeah, you're right. All right, let's tap out. So come sign the attendance. And that's it. Yo, that is in